The last video in our series is learning how to use the Excel function to calculate hypergeometric probabilities or probabilities based on the hypergeometric distribution. So a quick recap. When we have a random variable that counts the number of successes that occur when trials are not independent, we find that the probability of a success is no longer constant. Also, we will use the hypergeometric distribution if we are trying to select n items from a total of capital N items without replacement. So here there are quite a few arguments that need to be put in, but just be very clear as to what needs to go in which position. So like the binomial, like the Poisson, your first argument is always x, which is a specific value for the random variable. And then the next three are going to be your parameters. So n is going to be your sample size. How many are you selecting from your capital N, which is the total number of items in the population, or what is available for selection. And your K is going to be the number of items of interest. When we look at an example, you will see how clear this can be identified. And true, false, again, will specify whether it is going to be an exact or a cumulative probability. So Stephen has 12 shirts in his wardrobe. I've taken the liberty of graphically representing it here. 12 shirts, 7 of which are blue and the rest are red. So if the rest are red, it means that the remaining 5 have to be red. He is going on holiday to the Drakensberg and he randomly selects 6 shirts. So out of 12 shirts, we want to select 6 shirts. So there's your small n, there's your capital N. Selecting 6 shirts from 12 shirts. What is the probability that he takes 2 blue shirts with him on holiday? Now, you can see that they've specified that 7 of which are blue. So this is the K value that we are looking at, the bit of information that they've given you specific to a particular outcome. So you've got 2 blue shirts he will take with him on holiday. Let X then be the number of blue shirts selected. Clearly, sampling is done without replacement. If he's to select the 6 shirts, he's not picking one and putting it back and picking one and putting, he's selecting them. Each one is a distinct selection. We can therefore use the hypergeometric. We want to calculate an exact probability, meaning the probability that X is equal to 2. Just delete this. Okay, so we want to calculate the probability that X is equal to 2. So again, let's now try and put in all the information that we have. Insert function. We're going to type in hypergeometric and let's just say go. So there it is, hypergeometric.dist. Right, let's follow the instructions. We want 2 shirts to be selected. Number sample is the size of the sample. So how many do you want to select? We want to select 6 in total out of, we know, 12 shirts. Your population is the number of successes. We have 7 shirts that are blue. That's when we'll have a success. And we know that since this is an exact probability, we're going to type in the word false. Say OK, and this now gives us our final outcome. Remember, we want it to 4 decimal places, so let's reduce this, okay, to 4 decimal places and just neaten up our answer.